Hi there, everyone. Thanks so much for joining the webinar, Demystifying Advanced Analytics to Predict Donor Behavior. My name is Andrea Steffes-Tuttle. I'm the Marketing Director at Lytx. And to kick things off, I'm going to go over a couple of logistics. First, our webinar is going to last about 30 minutes, and at the end, we'll be taking Q&A. So in order to submit questions, don't use any of the hand-raising tools. Just go ahead and use the Q&A tool that you'll see in your browser. And all you have to do is select that Q&A, and a little box will pop up where you can actually submit your questions and send it to us. Feel free to send questions throughout the webinar, but we'll be reserving the Q&A portion until the end. If you're having any technical problems, feel free to use the chat box. I'll be monitoring the chat box and the Q&A throughout the webinar. So just give me a heads up if you can't hear us or if you can't see, and we'll be sure to address that. All right, enough housekeeping. Let's dive in. I'm going to hand things over to Gary Robinson. Gary is COO of Lytx. He's a 22-year veteran of marketing, analytics, and CRM. He works closely with nonprofit clients like AARP, the Partnership with Native Americans, and others, supporting and guiding their efforts to improve marketing results through the use of advanced analytics. He is a bona fide data nerd with a master's in statistics, and today he's going to demystify predictive analytics for us. Welcome, Gary. Take it away.
Great. Thanks, Andrea. Are you hearing me okay?
I am, yeah.
All right, and welcome everybody. Thanks for joining in this webinar. I think first I'll just give you a little context for who Lytx is. We're a software and consulting firm. So we have a cloud-hosted platform that I'll be using today to demonstrate sort of the data science behind donor behavior. But then we are also consultants, as Andrea said. We've been practicing data science for a long time, and so we're really able to help our clients sort of work through their analytic needs. And so let's talk about the goals for today. We've got a really sort of short timeline because we want to get in and get out for you. We want to share some of my perspectives on sort of doing analytics for nonprofit, arm you with some information from this that'll help you make better decisions going forward, and really just advise you on the application of modern analytics in a nonprofit setting. And so we're going to go through what I might term as the common analytics approach that you may be using or you're familiar with, kind of what we'll call the data scientist approach. Do a demo and then look at the benefits of this, and then end with any of your questions that you have asked during the course of this. So let's talk about the common approach. Hopefully you're all quite familiar with RFM, recency, frequency, monetary value. So when it comes to your campaigns, this is the most common approach, and it's extremely powerful and works well. You might be familiar with a matrix like we're showing on this page, where for each of those dimensions you might assign a value of 5 to the better segment, and 4 to the next, and down to 1. And so you get this cross of these 3 different values. And in this example, there's some different color coding to help understand. And you go through this process of kind of cherry picking, which segments ultimately, these sort of granular segments you want to market to. And this is usually done in Excel. There are tools that innately use RFM in this manner. But usually it's fairly laborious. It can get way more complicated, obviously. You can have big spreadsheets with all kinds of different metrics going on inside of these things. And so what I want to talk about today is kind of like I said, the data scientist sort of version of this. I mentioned on here that the role of promotion history today is usually not used by most firms unless you are using a data scientist. And it's often because promotion history information is just much more voluminous. I mean, there's just a lot more of it. It's harder to tease out what's valuable about it. But I think you'll see from this data scientist approach that it's an avenue to using promo history. And I may reference, I'm working on a project right now for a nonprofit client, and gift history is way more powerful, but promo history definitely adds value to the decision-making process. And then also common today is just the lack of resources and expertise. There's definitely a movement afoot to what they call democratize advanced analytics, pushing down what used to be deemed advanced and now is kind of being pushed down to more of the business analyst who doesn't have the data science background, to allow that person to do more advanced things. And I think that's some of what you'll see today. So the fact that there is a lack of resources, I think, necessitates the need to do much more streamlined things like you're going to see today. If you're taking, kind of a number of people or a significant amount of time to figure out your selection strategy, that's time that you could definitely have back. So in talking about the data scientist approach, I like this chart from Gartner, and most people, certainly in the data science analytics community, are quite aware of it. But I like it because it does show this analytic progression that is so common. And you may have heard of some of these terms, this notion of descriptive analytics and diagnostic, predictive, and prescriptive. As you can see here, as you move up that progression, you increase in business value, but you also increase in complexity. And so for folks who are doing any analytics, they're usually doing something on that lower end naturally. More reporting. Descriptive is what happened. Give me all kinds of information on what happened. And then diagnostic might be a little bit more of a BI tool. If you're using like a Tableau or a Power BI or something, you start to kind of hunt and peck and try to understand, well, why did it happen? What you're going to see today is it's not that difficult to move further up this into the predictive area. And so what will happen, being able to know ahead of time. And you can get some predictive insight naturally from these lower ends, but it requires more on the part of the person, and you're sort of not getting the value of the machine or the tools to give you better insight. And then finally, there's this whole prescriptive element where it's literally telling you how you can make it happen. It's this idea up there, now kind of commonly called AI and things like that, where it's telling you specifically, here's what is recommended that you do. And you could view all of this as just increasing your ability to make better decisions. That's the way I really view the work that we do is, if it's kind of like the autopilot. If you want us to, to fly the plane completely, we can, but our preference would be to inform you, use your years of experience in combination with the better insight you're getting to make better decisions. And so from these different levels, you get kind of this data insights piece, looking at the raw information and seeing where the holes are in it, and trying to make sure you've got a solid foundation from the raw data, to getting some general customer insights like profiles and such, to moving into that predictive where now you really understand relationships. These models are not just sort of telling you what's going to happen, but it's also in essence telling you what the connection is. Why is it going to happen? Which is what you're kind of looking for in those lower levels. And then there's an automated implementation process that can be built into all of these, regardless of tools, usually. And then ultimately an optimization, which is, gets overly used, but it is what should I do? What's the best thing I could do? And that can get really complex at times. So it's all the more handy to have tools that do it for you. All right, so let's go over to a different application. I'm just going to go over to Google Chrome. And I am in our Lytx IQ platform. And like I said, there's a lot of tools out there. So this is just going to be one tool example. And what I'm not interested so much in showing you anything about the features of the tool, but just making sure I'm sort of this demystifying the process. You may be actually kind of disappointed that it's not more complex, but like anything, once you get to see a little bit kind of how the soup is made, as it were, it's like, really, is that it? I thought there was more to it. There's always more layers. So I'm going to show you fairly simple example, straightforward, and hopefully by extension you can see how you could just add more onto this, and certainly it can get more complex. So what's great about donor behavior is of all the information that's available, the most powerful is the gift history. That's what that RFM is based on. And so you already know that that's really powerful, but it's only really 3 pieces of information, right? So this is a table that we're going to be using. This is actual donor information. that we're looking at. And so we've got an account number, sort of a member ID, and an amount that they gave, and a date that they gave. And we typically like this over sort of last 10 years. Less time, works. More than 10 is sort of unnecessary, I'd say. So not a lot. I mean, and in terms of being able to access this information, hopefully it's not something that you would see as too arduous. I mean, there is oftentimes an issue when you're trying to use data science methods that data availability is poor. But I think oftentimes people have their ability to get their hands pretty easily on just these three fields. And so in this example, we've got 818,000 records. And if we just take a quick look at just some summary information about these, you'll see that, like in this amount, anywhere from $1 up to $4,931. Generally, we will filter out things over 5,000, maybe 10,000, but usually over 5, kind of those large gifts kind of have a reserved area. We're really trying to mostly understand the gifts that are within a range of 1 to 5,000. This data set is actually not as long as 10 years. It's only going from 2011 through the end of 2016. And what I'm going to do in this example is I am going to focus on 2016 gift giving in comparison to all the giving that came before 2016. So we're going to use just recency, frequency, monetary value from 2011 through 2015 to try and predict who gave in 2016. And I think the only other thing of real note here would be that, in terms of accounts, these IDs, we got 818,000 records, as I mentioned. But if I scroll over a little bit, there's unique values is only about 300,000. So naturally, you have a number of people who gave multiple times, which is what you'd expect. So hopefully this data set looks pretty familiar to one you might be used to, or you can understand it well enough. One other thing I want to show you is in the setup for this, we put those RFM values into some buckets, and I just want to define these buckets for you. So we're going to create a recency segment, a frequency segment, and a monetary value segment. And I think these definitions that we use are pretty common. So in this little bit of code here, we're looking at number of days. So if a member gave in the last 178 days, we're going to define them as having given in the last 6 months. 534 days would have given in the last 6 to 18 months. And it kind of goes down like that. So our buckets are 0, 6, 6 to 18, 18 to 36 months, and then you get 3 to 4 years and 4 to 5 years, or 5 or more years. So those would be the recency buckets. And similarly, like with the frequency, is the number of times that someone gave. And this is over that entire period we were talking about. So did you give 1 time, 2 times, 3 to 4 times, 5 to 9 times, or 10 plus? And one of the things that I think is interesting is, well, why these buckets? How did you decide on these? And usually that's just kind of convention. I think these are fairly standard. You may use slightly different buckets, but by virtue of even putting things into buckets, you're immediately reducing the amount of information that you're looking at. Now, it's for good reason, because you're typically doing this in Excel or something, and you need to create these categories. But from a data scientist perspective, we don't like to lose information. There's valuable information in the values in between in these buckets. And so you'll see what I end up doing is not using the buckets ultimately. Now, it may be that using or not using the buckets doesn't always make that big a difference, but it tends to make a bigger difference when you have more information. In this simplified example, we just are only going to focus on recency, frequency, monetary value, and so there's sort of not that much sort of total information available to us. But what I will often do is I'll take that gift history and I'll create all kinds of other types of related information out of it. So sort of like I call it like velocity. Are donations for these members increasing, decreasing, or are they flat? is the average gift amount increasing, decreasing, or flat? So I create variables like, what percent of your total gifts represent your last gift, or your second to last gift, your third to last gift. These things, just add, in what would be in a traditional spreadsheet approach, just unmanageable complexity. But from a data science approach, they're all very easily manageable. All right, so we've got these segments. And so what I'm going to do is I'm just going to show you kind of what you, again, kind of giving you sort of level setting in all this. So let's do a view on this. And we're just going to look at kind of like a recency here. And so you've got sort of this, the bars represent the dollars per name. So this is the total amount of dollars that were given divided by the total members that fall into that bucket. So it's not average gift. It includes people who gave nothing. And so we're looking at historically people who gave within the last 6 months prior to 16. Prior to 16, in the year of 2016, they gave $29.50 average dollars for all the people in that bucket, of which there were 4,027 members in that bucket. So we see that the number of members is highest in the 18 to 36, but we see this huge, nice decrease in dollars per name. And so naturally, we like to go after 0 to 6 and next after 6 to 18. And so you get kind of similar things with each of these different RFM buckets, similar descending, but, frequency 10 plus is great, but you hardly have any people in there. And these numbers are kind of small because I just took a random sample. I should have noted that. There's 888,000, but this is just a random sample for the purposes of easily kind of showing you. So you get this great, sort of descending dollars per name. And this is why RFM is so powerful, because you do get a really nice rank ordering, with these different segments or dimensions. And this is monetary value. So monetary value really high for people who have given 5,000 or more, but there was only 7 sort of in the sample there. And everybody is over in this, $0 to $100. All right, so I think everyone gets that. What you often end up with then with these, like I said, is kind of that RFM table. It looks something like this. And so let me just drag down here, recency. So you get recency, frequency, monetary value, and you have all these cells. This is just the number of people, but you might also obviously look at like the average amount given, which is like the dollars per name. And you might cherry pick in here, as we said before, kind of who you want to target. And it's time consuming and all that. So what a data scientist would do with this though, is he or she would build a predictive model. And so there's lots of different tools that build models, but they're now this democratization of data. They've made it quite easy. And in Lytx IQ here, all we have to do is point to the data set that we're going to analyze and point to the field that represents the dollars, let's say in this case. And we're just going to pick 3 predictors, just frequency, monetary value, and recency or whatever. And these are not those buckets. These are just, this is just the amount of time. This is the actual value, somewhere between, 0 and 1,000, or how many times have you given? What's the actual value, not the bucket? And so we're going to build a model off of that. And so that's it. We just have to fill those out, and we can run that model. And in this case, and there are lots of different types of models, we're doing what's called a decision tree, and it would default to that as one option. And so a decision tree comes out really nice and sort of easy to understand. And so I have to hit view it here. And so it looks kind of like your matrix, but in this case on its side. So this, I wouldn't say looks easier so far. So I'm not saying that this is the final step. But what this is doing, just to explain, is it's taking your total population that it analyzed, and it's saying the average is $8.32 per name. And so it's saying, well, the number one thing that I would split on is that monetary value where we saw that big difference. But it's going to split on $470. Who would have guessed $470? Why is it splitting on 470? Well, that's what's creating the biggest difference between the dollars per name. It's saying that I get an average of $5.75 per name versus 254, where I've got enough people, 304, to have reasonable insight. And it goes along, and then it further splits, each of those buckets. It keeps finding where these split points are. And so it's not cherry picking, because it's saying you got to be greater than or less than some value. It's not, because the problem is if you just cherry pick cells that aren't sort of next to each other, it may have just been in that one campaign that held up. It's much more reliable when you sort of pick these kind of values increasing or decreasing from a single point. And we want what we decide to do to hold up over time, obviously. And so you end up with this sort of big decision tree. All right, so that's interesting. You get to see where all these are. But what you really want are ultimately is sort of a final score. And so what this does is it pushes out an actual score. So when you build this model, what comes with it is that decision tree, but it for each member, it gives you a prediction. So from that decision tree, using that sort of criteria, it gives you an expected dollars per name for each member, and then assigns them to, in this case, just a quartile. We're just going to assign them to a segment of 1 through 4, because we don't have enough information to split them up really in any more than 4 segments. And so 1 is going to be the best, 4 is the worst. And so now I have this predicted amount that they're going to give, and this rank ordering as to how they compare to the others. So let's go back over to our insight, and let's see how these compare to what we were just looking at. So I'm going to go to just a different library where I put the similar chart to what you saw before, but now this is the modeled approach. And so it looks kind of similar to what we were looking at, mostly like with Recency or any of the others. We get this, the bar represents the dollars per name, so we're $27.94, dropping all the way down to $3.90 to $1.50. So what you'll find is, and I'll show you in comparison, is you're able to get a much steeper kind of slope here, much more like drop off with more names. So this is 7,000 members. And then it goes to 44, 10,000 up here. So these do kind of fluctuate a bit. And sometimes you'll get sort of ideally kind of flat, but we don't have again enough information to kind of have everyone in equal buckets. But you're getting a good amount of names at the highest performance possible. And if we look at this in comparison to RFM, we'll just take a quick look at our dashboard on this. So these are the charts that we were looking at before, but now we can look at them together. I mean, Recency really stood out to me because you're getting $29.50 per name. So this is 2016 average dollars per name for people who had given 0 to 6 months prior to 16, but only on 4,000 people. Here, your dollars per name are slightly under, but on 7,000 people. And the drop off is much more precipitous. And you also, with this thing, all you have to do is mark it to segment 1, or you can mark it to segment 2 if that still is good enough for you. But you don't have to worry about crossing all of these different RFM segments, right? I mean, it just removes all the complexity. And so what you end up with out of this is just a new segment assignment. So instead of RFM, we might just call this, model quartiles. And it's pretty easy to select one and decide whether you want 2. You're only picking amongst 4 options instead of, all the other options with RFM. And so if I jump back over to our PowerPoint, and let me put it back in presentation, we're quickly wrapping this up. So hopefully what you see from this is that through kind of this really simple data science approach, you can improve response rates and or reduce costs, which I'll show you an example, and then reinvest savings. So the final sort of chart I have here is if you just look at this top table, if we have a typical situation where a campaign, let's say, was 1 million names, and we are getting a 3.87 response rate, and it was costing $400,000. That would result in a net revenue of $180,000. Well, it's not that difficult to improve response rate by 10%, through more of this sort of data science approach. And so if we say, well, if I can improve my response rate 10%, what if I hold my net revenue the same? What if I just want to achieve the same net revenue? I can actually mail 24% less. And so I can save $97,000 out of that, $400,000. So I can save ultimately about 24% of my cost. And so you can walk away with that savings, or you could say, you know what, I want to spend it. I'd like to grow my net revenue. So let me reinvest that net revenue and mail more. So I'm going to mail another 243,000 out of that. And so I'm going to, in this scenario, then I'm going to spend that $97,000, and that's going to generate an extra $58,000 in net revenue for me, or a 32% increase in net revenue. So this process gives you better performance, like better options. You're able to make faster, better decisions that improve your process. And like I said, this is really just the tip of the iceberg, because it's a super simple example, but you can layer onto this a lot more predictions. You can build these kind of models around how much are they likely to give, how often should I reach out to them. All of these things that you otherwise wouldn't know is really available to you in this sort of simple process. All right, that was it in a nutshell. So I know it was fast. So it was this balance between not taking up too much of your time, but wanting to demystify this. And we're certainly available if you have any follow-up questions. But if you'd submitted questions, we can take those now. Andrea, did anybody ask anything, or would people like to ask some things now?
Yeah, I have. Yeah, feel free to submit questions. One question that was posed during the presentation was, how do you determine what to market? So you've sort of identified the group that you want to market to, but how do you determine what to market?
Yeah, good question. So one of the benefits of the RFM segmentation is you do get these sort of donor profiles a little bit. You get these sort of segments of, sort of lapsed donors that when you look at the RFM, or you might have transition from new and things like that. And so what I showed you didn't contain that. It was just optimized, just on who you should market to. So the question now that's being asked is, okay, Gary, I like that, but what do I market? My answer to that would be is that we could still look at those segments that you're interested in relation to how they're likely to perform, and still use what you do today and say, all right, well, I know to my laps, this is what I like to market. The data science approach, though, would be to say, I've got some data where I've done some testing. I've tried different premiums. I've tried different things. So can you use this data science approach and analyze that, and ultimately tell me what's the best creative or the best premium for the best member, for each member. And so there's another webinar that we're going to be doing coming up, in which we show just that, where we've got a little bit more complexity, and we're able to optimize the creative and the premium to the member, and to ultimately drive even better performance. So it's this ability to analyze data and ultimately see what works, and from a kind of a machine learning to inform you. And then you take that information, decide whether you like it or you want to tweak it. And so the answer is, Andrea, that we would just kind of apply the same approach, and it would tell us what the best offer creative premium is.
Awesome. Thanks, Gary, and thanks for that question. Another question that just came in was, how long does something like this take?
Yep. It really, the thing that probably takes the longest, which as I said in the beginning, is usually getting the data together. And given that this data is usually readily available, this can be done very quickly. So really, time is not a factor in this. If you're thinking, oh, this is too involved, this type of analysis can be turned around, by any kind of data scientist very quickly. So it's only when you get into even more complexity, but I would argue that when you get into more complex situations that take longer, you're either not doing those at all today because they're too complex, or you're taking way longer than it would take this approach to do them. So time would never be, if anything, this is always a huge time savings. So you can turn this around in a week. To give you a hard number on what I just showed you, you could easily turn this around in a week.
Got it. Thanks, Gary. There aren't any other questions. If someone wants to submit another question in the next minute or so, feel free. If you have questions that you want to follow up with Gary on, his email address is here. We'll also be sending a recording of this out to our attendees, so you can look for that in your inbox and feel free to share with anybody else who might be interested. And other than that, I think that's it, Gary, unless you have anything else you want to share.
Nope. I hope this was useful to everybody, and I'd love to hear from you. And have a great rest of your day. Thank you for joining.
Awesome. Thank you, Gary.
Thank you. Bye-bye.